Hello everyone. In this video we are going to cover a very interesting topic, and that is what is the difference between 32 and 64-bit processor. I'm sure a lot of people ask this question when they go buy a computer. But nowadays a lot of computers, I would say most of the computers come in 64-bit processor, as 32-bit is an older version or an older model of computers. All right, so let's get into what is the difference to clarify what's the confusion that we have. A processor, first of all, is the same as CPU, which stands for Central Processing Unit, which processes the instruction that come from programs, the operating system, or other components in your computer. All right, so let's put it this way. CPU, we know, gets the unit of data or that information from RAM. RAM is memory, and when it gets it, it processes it. Now, if your computer is 32-bit processor, then it can only process 2 power of 32 memory addresses, and that equates to 4 gig of RAM. So it means your computer cannot process more than 4 gig of data at a time. All right. Now, in computers, there is only binary. We know that. It's only 0 and 1. Each one is considered a bit. That means for 1 bit computing, you get two possible values. 2-bit means four values. Then at 3 bits, you double that to 8. All right, let me put it in a graphical way. So the picture speaks 1,000 words, right? So we have our computer, and we want our computer to do the computation of 2 plus 2. Now, there's one thing we do need to understand, that there are 8 bits in 1 byte, and 1024 or 1024 bytes in 1 kilobyte. 1024 kilobytes equal to 1 meg, 1024 meg equal to 1 gig, and so on. Now, going back 8 bits to 1 byte. So 2 has 8 bits, another 2 has 8 bits. So this is how it is right now sitting on your disk, because computer doesn't understand any other language but 0 and 1. So when we do 2 plus 2, it's basically going to do 0011 0010 plus 0011 0010. And then from the disk, it's going to pull that information. If it is saved, then it's going to hand it over to your memory. Okay, memory. If it is 4 gig of memory, it could actually capture the entire 4 gig of your data units, and it could hand that over to the CPU to process it. Now, if your CPU again is 32-bit, then that memory cannot let CPU process anything more than 4 gig. It has to be equal or less than 4 gig of data. That's what really a 32 versus 64-bit processor is. Okay, moving on to the next slide, we will look at the chart, which is our values for our exponents. So 2 to the 0 value equals to 1, and 2 to the 1 equals to 2, 2 to the 2 power equal to 4, and this is the basic mathematics that we have learned when we were kids. So that's the what we call an exponent value. So you do 2, if it is 2, then 2 times 2. If it is 2 to the power to 3, then 2 times 2 times 2, then equals to 8, and so on. So if we keep going and keep going to 2 to the power 32 and put it at as exponentially, then eventually you're going to get the 32-bit worth 4.3 billion. It means it could process 4.3 billion of data units at a time if it is a 32-bit processor. Now, if it is a 64-bit processor, which is going to be 2 to the 64th power, is worth, wow, 18 point quintillion and change. That's so much I cannot even translate it into how many gigabytes it will be. So now your processor, it becomes so powerful that it could process so many of that data unit in a shot, and it could take that from your memory. So it usually doesn't happen, but let's say if your memory has a 8 gig, and your processor is 32-bit, it's not going to work because your processor can only handle 4 gig at a time. If you want your computer to process more than 4 gig of memory, then you need to have a 64-bit processor. All right, so again, let's look at this. This is the our value 4.3 billion. When we divided it divided by 1024, that equates to 4194304 kilobytes. Now, if you take that same value and divide it by 1024, that equates to 4096 megabyte. If you take that same value, 4096, and divide it by 1024, that equates to 4 gig. And that's what the 4 gig is about, the memory card. If you have a 4 gig of memory card, then you could have 32-bit of processor. But if you want a bigger or higher memory, then you cannot go with 32, you gotta go with 64. Let's look at the quick brief history of our processors, how they came into being. The Intel 8080 chip in the 1970s supported 8-bit of computing. That's so low. Now, in 1992, Windows 3.1 was the first 16-bit desktop version of Windows. Then came the AMD. AMD shipped the first 64-bit desktop chip in 2003. Apple made the Mac OS X version, the 10 Snow Leopard, entirely on 64-bit in 2009. And then moving on to smartphones, the first smartphone with a 64-bit chip was iPhone 5S in 2014. So as we're moving into the new eras, this processing speed is increasing. The demand for running our applications and those application requirements to have certain memory is increasing. So that is why your 32-bit processor cannot actually accommodate that type of computation at one time. So that is why all of our computers nowadays coming with 64-bit processor.